Indian Institute of Technologies are one of the most prestigious technical universities in India. They are a dream college for millions of young Indians. Every year they have this highly competitive exam called JEE, or the Joint Entrance Examination. This exam is taken by close to 1 million students. The exam is considered to be hard and only a few qualify to attend the prestigious IITs. JEE has two parts, mains and advanced. Only the students who clear mains can move to the advanced portion of the test. So how hard are these questions? Can someone solve them with just moderate grasp on mathematics and Python? Well, turns out one can, and with Python it is easy. Before we dive in, please do not forget to subscribe to the channel and click the bell icon to get notified when we release a new video. We said before, JEE has two parts, the mains and advanced. The advanced exams are harder. Today we are going to take a look at one of the math papers of the JEE Advanced Math exam from 2022. We will solve it with Python and some basic mathematics knowledge. Now let's dive in. For the purpose of this video, we are going to use SymPy, a symbolic computing library for Python. To know more about SymPy and symbolic computing, please visit the link in the description. All our code is available on GitHub and link is in the description. This is the maths paper, let's look at it. It has section 1 with 8 questions, and answer to each question is a numerical value to 2 decimal places. Section 2 has 6 questions and each question has 4 options. You get full marks if all correct options are chosen, partial marks if you chose some of the correct options, and negative marks if you choose an incorrect option. Section 3 has matching list questions. So you have to choose the option that has correct mapping. The marking scheme is you get full 3 marks if you choose the right option, otherwise you get negative marks if you choose the wrong option. Also, you get 3 hours to solve this question paper. Now that we know the organization of the question paper, let's start our code to solve these questions. We are going to use a Jupyter notebook, my personal favorite to solve these kind of questions. I have created a notebook to solve this. Remember, I am going to share this notebook on GitHub. Start with prerequisites. I am going to install a few packages here, which are my go-to packages. Some of the packages are SymPy, NumPy, Matplotlib, a plotting library, and Matplotlib Venn, a plotting library for Venn diagrams, as I saw a set question in the question paper. Run this and they are already installed, so it quickly runs. Let's import packages. Go to question 1. This looks like really straightforward, just type the formula. That is about 2.36 rounded to 2 decimal places. Okay, question 2, this is limit question. What is alpha? Okay, alpha is positive real number. What if we keep alpha as 1? That will simplify the question. Type f of x and g of x. Value of limit f of g of x as it approaches from positive side. Let's look at g of x. So g of x cannot be further simplified. Let's plot the values of g of x near 1. I have taken the epsilon here to be really small. I guess I might be seeing a floating point issue, but looks like g of x as x tends to 1 is approaching 2. f of 2 is 1 by 2, that is 0.5. Now question 3. This is a set question, and thankfully we have imported a library for visualizing sets. Okay, pandemic data of 900 persons. Let's just visualize the sets in a Venn diagram. What does the question ask us for? Is it the common regions? Person is chosen randomly from these 900 persons, then the probability that the person has at most 1 symptom. That is 0 or more symptoms. So the answer is 900 minus the any intersection between sets. Find the value of all unknown regions and calculate the answer. Well, our answer is 4 by 5, that is 0.8. Question 4. Z is a complex number. Since the given fraction is real, so the imaginary part must be 0. And the imaginary part is 8xy plus 3y. Means x is. We know the number is real, so a conjugate is equal to itself, hence value of imaginary is. There are 3 values, and since y is non-zero, the value must be one of these. So we can pick any of them since they only differ in signs and we are only concerned with square of magnitudes. So answer is 0.5. Question 5. C is complex conjugate. The question asks for number of distinct roots. This is straightforward in SymPy. Let us just type the equation and, voila, the answer is 4. Great, that was easy. Question 6. Let L1 to L100 be consecutive terms of arithmetic progression with difference d1. Let W1 to W100 be consecutive terms of arithmetic progression with difference d2. Just write the formula for area as a function. For d2 we can substitute it with 10 divided by d2. After simplifying the equation of formula, it looks like the unknowns in answer can be cancelled by 10 times the difference between area of 51 and area of 50. Hence, the answer is 8,900 plus 10 times 1,000. Question 7. This question is really simple to do in Python. Let's just write a function for it. So the answer is 569. Question 8. This question is based on circumcircle of triangle. Honest geometry problems are hard to do with SymPy. Although SymPy has methods to find circumcircles for polygons. We can simplify this problem by assuming the A is on origin. Then both sides will be on x and y axis. The radius be small r. This is what we need. Since the circle touches axis, it has a standard equation that I looked up combined with the condition that it is touching the other circle. Let's plug this equation and solve for radius, and answer is 0 or a non-zero value. Since r is greater than 0, the answer is the non-zero value, that is 0.84. We are now in section 2 with multiple choice questions. Question 9. This looks like a complicated integral. Let us just type it. And now let us just evaluate it. This looks like it cannot be 1 or 0. Also, the numerator is 2 by 3. Let us solve this for a. If we are interested in finding if the number is rational or not, we will introduce a dummy variable so that SymPy gives us an answer in symbolic form. Like answer is irrational and has 2 roots. So options C and D are correct. Question 10. This is another arithmetic progression question, so let us just write it as Python function. And we have evaluated all 4 options and only B and C are correct. Question 11. Equation of a plane is given. I am not sure how to do this in Python. I'm going to skip it. If any of you know how to do this in Python, please let us know in the comments section. Let us skip to question 12. This is another equation of a plane. So there is a point Q that is reflected in a plane and reflection is point S. It means the midpoint of Q and S is on plane. We can solve the equation of plane by substituting midpoint in equation of plane. Let's evaluate all the 4 options. For options A, B and C solutions exist, but option D the value is minus 129. Hence, only options A, B and C are correct. Question 13. Given is an equation of parabola and there are a pair of tangents from point P to point P1 and P2. After looking up the equation of tangent for parabola, let us find all points in question. Thankfully, SymPy allows us to find perpendicular lines easily. So we now have all 4 unknown points P1, P2, Q1, Q2. As we did before, let us now evaluate all 4 options. So B, C, and D options are correct. Question 14. This looks like an intimidating question. Let us first see if we can simplify it. That is much better. F and G are simpler functions. Let us plot G and find the minimum and maximum values of G as the question asks. Minimum value is 1 and the maximum value looks like root 2. Let us now write P as a function and evaluate all 4 options. Only options A and C are correct. Finally, we are in the last section of the paper. Question 15. Let us evaluate all the options. Item 1 matches P. Item 2 is a tant function which is periodic. It will have 2 values in a given interval. Hence, option 2 is correct. Question 16. This is a probability question. Let us just simulate the entire thing in Python. Looking at the question, we can just evaluate first and fourth option to find the answer. So the answer is option A. Question 17. P, Q, and R are terms of a harmonic progression. Let us just write harmonic progression as a function in Python. We solve for Q by R equal to 10. Then A is equal to D. Let us substitute the value of A as D in P, Q, and R. Like P by Q is equal to 10. So if list item 1 is true, then list item 4 has infinite solutions. Let us now solve the linear set of equations in SymPy. Looks like list item 1 can be T and Q. This question is confusing. Let's evaluate list item 2. Okay, it has no solution, so correct option is option B. This was a tricky question. Question 18. I've given an equation of ellipse and tangents. We looked up equation of auxiliary circle and tangents. Let us solve them using SymPy to find unknown points. Points E and F are. Point G is. Hence, the area of triangle F, G, and H is. Let us just evaluate list item 1 and 2. List item 1 is 1, so option C or D are correct. Value of item 2 means option C is the correct answer. Finally, we are done with all the questions. A lot of fun solving these problems in Python. Please do let us know if you liked our video in the comments.